Hello, everyone. My name is Kyle Demes. I'm the Chief Operating Officer of OurResearch, OpenAlex. I'm really excited to be speaking with everyone today in Japan. So thank you very much for having us and for organizing this. At a glance, what I'm going to talk about is what OpenAlex is. We just had some really great examples of what you can do with it, why you should use it, how you can use it, and then an interactive demo and Q&A. And please feel free to put your questions in the chat. I really want to make sure that people are asking questions and I'm getting to answer them. Okay, we think about this as a concept of research intelligence. And the idea here is that if we collect data on research activities, researchers, what they're publishing, who's funding them, then we can get intelligence from that data and turn that into better actions. And that includes everything from finding the exact publication you're looking for when there's now 10 million publications a year, all the way to governments trying to understand the impacts of the research that they've funded. The problem here, or the foundational challenge we're trying to address, is that when a researcher publishes a paper, you can see this is a university, when a researcher publishes, their university doesn't decide what they publish. The peer review community of the world decides what they publish, and that's really important for the quality of science. But that means institutions, universities, governments, they don't have a list even of all the publications that they are publishing. That also means that they don't have data on other universities. Scientific knowledge graphs, or SKG, solve this problem. If you take here as an example, we have one of my publications. We've extracted information on that, on who the publishers are, what the source or the journal was, which institutions and authors are part of this work, the funders, the abstract, who cites it, all of this information, and we've created linkages between these. So institutions and authors and funders and topics are all connected. If you haven't heard the term SKG, or scientific knowledge graph, before, you have probably heard of one of these. Web of Science, Scopus. Google Scholar is a little bit different because you can't access all the information in the same way. But otherwise, these databases are structured very similar. I'm just going to talk today about OpenAlex, which is very different because it's totally comprehensive and completely open. And I'll speak to that a little bit more. So first, it has broader coverage than any of these other knowledge graphs. And that's really important. And I'll show you a few examples of that. There have been hundreds of studies that compare Web of Science and Scopus and dimensions, but OpenAlex is only a few years old, so there's fewer of these, but already there's a couple hundred publications. These are a few recent ones to show you. If you look here, Scopus and Web of Science have largely the same content coverage. There are some important differences, but they're mostly the same. When you layer on OpenAlex, OpenAlex has almost everything that Scopus and Web of Science has, and quite a bit more content that isn't in there. This is a great publication to look at. This one in the middle is a screenshot from an interactive dashboard that the CWTS Open Leiden rankings have created. I find this to be a very useful tool because you can zoom in and see where those differences are. On the x-axis, we have the Web of Science-based rankings, and on the y-axis, we have the OpenAlex-based rankings. And so if everything were on the line, they'd be exactly the same. But what you can see here, and I selected country Japan and field social science and humanities, is that there's quite a bit more social science and humanities research in OpenAlex than there is in Web of Science. And then over here on the right is another recent example. I was a collaborator on this paper where we started with all of OpenAlex, and we limited it to just what's in Scopus as well, and looked at rankings to see how much do things change if you use just the part of OpenAlex that is in Scopus. And you can see, except for the very small countries, you get very much the same sort of result, even though this is a completely open and free database. Two more quick examples I want to share. On the left here is a new paper that looks at the coverage of open access journals in Scopus, Web of Science, and OpenAlex. On the left, these 25,000 journals that are all of these are open access. OpenAlex has 25,000 of these that aren't in any of the other databases. And you can see here, Scopus and Web of Science have very few unique open access journals. They have a lot of proprietary closed access journals. And then on the right, you can see this is a recent paper from CWTS and a PhD student there that looks at coverage of African journals, just to show that OpenAlex has much more coverage of African journals than Scopus, Web of Science, and other competitors. And that's the same with Japan, with China, with the Middle East, all areas of the world we're trying to be completely comprehensive to. But we're not only broader, we're also completely open, and that is a major feature for us. I won't spend too much time talking on this, but even for institutions who are committed to open science, you know, there are other limitations that are good to know about with these closed SKGs. Their subscriptions are costly, and they get more expensive every year. Their results can't be shared. So if you're a researcher studying research on research or the science of science, you can't share your results. Or you can share your results, but not the underlying data to be able to replicate it. And then, of course, if you're a government or an institution making decisions based on these databases, you also can't share that. And we think that's really a tragedy. And it's something that's preventing science from developing even further. But really importantly, you inherit their exclusiveness. If Scopus doesn't index something, if Web of Science doesn't index something, there's nothing you can do to add that data to those databases. You can ask them to add it, and there is a process, but it's very difficult to do that under most circumstances. You can, however, if you don't want all of the things in OpenAlex, you can filter to just a subset that you want. So that's something to worth knowing about. You also can't build on them. So you can't build your own tool or derivative process. And I want to thank the previous speaker for that slide that showed the user group meeting of all of the great things that people are doing with OpenAlex data because it's open. Okay, so I won't spend much time on that. I want to talk about how you can access this data. So there's three major ways to access it. And the first is the one that is completely different from all of the others. So that's the OpenAlex snapshot. And you can see here, anyone in the world can go online and download the entirety of our database and use it for whatever purposes they want for free right now. You don't even have to register. You don't even have to tell us. No other database can do that. This is really great if you want to do large scale analyses or you want to build your own products, but very few people have the ability to use such a large database. So we also have a completely open and free API. You get up to 100,000 calls per day and 200 responses per call, so 20 million responses a day maximum. But that's very generous. That's more generous than even the Web of Science version if you pay for it. But that's very well documented and online, and anyone in the world can use that as well. And then the third final way, because not everyone can use an API, is we recently launched, I guess it's been about 9 months now, our first user interface. And this is meant to make it very easy to interact with OpenAlex. And anyone in the world can go to openalex.org, and I'll do that in a minute and show you how, to start interacting with the data immediately. Those are the three ways you can access it. Regardless of how you access the data, the use cases are pretty much the same most of the time. So the simplest way of thinking about this is you define a logic layer using filters. What country is involved, which institutions, which search terms. You use these filters to get a result set. These are the publications you're looking for. Maybe this is where you want to end because you just want a list of all of the publications at your university, or maybe you want to then analyze by some of these filters. So by Sustainable Development Goal, the UN SDG, or by institution, or by open access. You can then analyze that way. And I'll give you a few examples just to showcase sort of how this works. The first here is very common. We get asked this all the time. How well are we progressing towards our OA goals? So for the filters here, I used institution country is Japan. So these are all Japanese institutions, and open access, true or false. And I grouped by publication year. And you can see not open access started to decline. And open access has really started to increase very rapidly in Japan. And it was, I guess, around 2020, 2019, when there was more open access publications than closed publications. And this is the type of analysis you can do very easily to compare to other countries to see how you're doing, or for institutions as well. Another example is if you want to find collaborators. So an example here, which institutions in New Zealand are working on gender equality in medicine? I used as filters gender equality, a sustainable development goal, concepts of medicine and family medicine, country New Zealand, and I limited to small teams, so 1 to 10 authors. And then I grouped by institution. And now you can see here on the right, all of the institutions and the amount of publications that match that. So this is a great way for institutions to find collaborators on a specific topic. Okay, another common thing people do is benchmark. So as an example, how do countries compare in their publications relating to regenerative medicine over the past 10 years? So I use the concept regenerative medicine, source type is journal, the work type is not paratext, the years, and then I chose 5 countries, Canada, US, UK, China, and India. And you can see when you group by year, how those are changing over time. So the US was a leader in regenerative medicine for a long time and sort of plateaued in their research outputs on this topic. And you can see China, on the other hand, has really increased in the last few years to overtake now. It's not on this graph, but has now overtaken the US in research output on this concept. So this is a example of the types of things people are doing. But now I want to also show a few use cases of how institutions around the world are using OpenAlex beyond these very simple ones. The first one I want to talk about is the French government and their needs. So we partnered with them because the French government committed to using only open research information in all of their evaluations and wanting to move towards open research metadata. But they had specific concerns that kept them from being able to use open metadata. So we worked with them, we partnered to understand what those were, um, and then how we could fix them together. And these are 2 examples of big projects that we've been doing with them. The first is prioritizing affiliation work. French affiliation metadata is different than everywhere else in the world. They have really complex reporting structures for their universities in a way that no one else does. So they can't use open metadata unless that's fixed. And so we worked with them and collaborated with ROAR to get some of that work updated. We did some custom work with specific universities to try and fix those universities' records to make sure they were more clear. And then this tool, the Works Magnet, is a really great example of a collaboration where the French government created this tool, but it helps any user in the world make metadata curation around affiliations possible in OpenAlex. So any of you can go look at your institutions right now. You can do curation requests in the Works Magnet, and it will make OpenAlex even better for everyone. And that was a really great collaboration. But the other collaboration we've had with them is on ingesting HAL. If you haven't heard of HAL, HAL is a very large national repository in France with really high adoption. It's being used everywhere, which is really great. But their records aren't getting into Crossref and DataCite and all of these other repositories. So we worked with them to use HAL as a trusted source of information for OpenAlex so that when something new comes into HAL, it pushes to OpenAlex. And so this is the type of collaboration we can do at the scale of a country, a government, even with institutions. If they tell us we need this, we try and do that so that they can, whatever their needs are, to respond to open science. Another good example I like to show is because the data is open and free, anyone can use and create an external dashboard on their website showcasing our data. This is an example from the University of Washington in the United States, where they show all their international collaborations, and these are data coming from OpenAlex. Another really good example from the United States is it's called Collab Next, and this was started at Georgia Tech. And the idea here is they have some what they call HBCUs, historically Black colleges and universities, and often they've been underfunded. And now there's a big push to increase collaboration between HBCUs and some universities that do have more resources. This tool helps people at HBCUs find collaborators and helps people at larger institutions find collaborators at HBCUs as well. We were really excited to partner with them. They tried using Web of Science, but they were unable to because they exposed the data publicly. But we encourage them to share that. So it's been a good collaboration. Another very sophisticated example I like to show is EPFL in Switzerland, École Polytechnique Fédérale de Lausanne. They've mapped all of the research publications and all the topics at many universities, and then they create these fingerprints to understand how similar they are. So if you look, for instance, at EPFL, each of these dots is a topic that they publish on, and it's mapped at the scale of all the research in the world. And so if you look at ETHZ and EPFL, they have very similar fingerprints. So this is an institution that they see as maybe a competitor or someone that they're doing a lot of similar work to. Whereas UNISG, you can see they have a lot of activity in a space that EPFL doesn't have activity. So this is a really great institution for them to collaborate with. So this is an example I like to show because it is a very good, very sophisticated way to use the data. And then one more example I want to share. VOS Viewer, if you haven't heard of it, is probably the most well-used open source bibliometric analysis tool, other than things like R. Libraries love using this, researchers love using this. It helps show networks among bibliometric data sets. And historically, you've had to download data from Scopus or Web of Science if you had access to it, and then import that into VOS Viewer. Even though VOS Viewer is open and free, the underlying data wasn't. But now, because OpenAlex is completely open and VOS Viewer is completely open, they've built an integration so that you can copy and paste any URL from OpenAlex directly into VOS Viewer and start creating these visualizations. This example here is the University of Windsor in Canada, and you can see each dot is a different university they've collaborated with, and the color is the number of citations in those collaborations. So you can see the very impactful by citation collaborations. So those are all the use cases I want to share. I do want to say I've got some information here where you can go find how to contact us, documentation on our website, where you can find our webinars that we host. So I'll send these slides around. But I also now want to spend a few minutes doing a demo of OpenAlex, and hopefully there is some questions that come in and we can get to those as well. But I'll just go in. So if you haven't used this before, you can just go to openalex.org, and you can see anyone in the world can access this. You can do it right now. You don't need to authenticate. You don't need to pay. It's all open. If you scroll down to the bottom, you can find more information. Here's where you can download the data snapshot. Here's where you can find our source code, which is also open and free. Here's information on the API and a lot of information on about the data. But from here, you can start typing essentially anything you want. So I could, for instance, type my name. I have a very unique name. There's not many Kyle Demeses. So if I click on that, it's now bringing up all the publications from my name. So from my author profile. Regardless of what you search, you're going to find the same thing. On the left, you have all of the works. And then on the right, you have the analyses that you can perform. Now, this is really simple. These are just my publications. So I could go here and I could export all of these results. You can export 100,000 at a time. It takes a long time, but you can get through it. And then you can also refine this. So let's say I want to know just my open access publications. If I click on this, you can see it's added a new filter up here to say, Kyle Demes is the author and it's open access. So now these publications are open access. If I click on one of these, you'll see it pops up with sort of a window. You can access the landing page for that publication. You can also get a PDF when it's available. Now, this work, I'm just going to make my screen a little bit bigger. This work you can see is open access bronze. So if you click PDF, you'll get that PDF immediately. If it's open at the journal's website, you'll get it immediately. If it's open in a repository, you'll get it immediately. If it's not open, it's a closed access work, and you click this, it will go to the website and you'll have to authenticate with your institution. But this is all of that information. So I'm just going to click out of that now. These are the defaults, and everything in the user interface is meant to be easy based on what we think people want. But obviously, you can do a lot more. So I want to show you some examples. Right here, it has publications over time, open access, what topics they're on, the institution, the type. But if you click this plus up here, you can do quite a bit more. So you can see we have things like APC sum or citations, the countries that I collaborate with. If I click author, it's going to show you the authors that I've collaborated with as well. They show up there. Or I can click language, for instance. So I have not written any publications in Japanese. I don't speak Japanese, unfortunately. All of my papers are in English, but you could do that type of analysis here. You can also click more to see we have quite a bit more information. I think there's 50 something filters in here now, so quite a bit of information. If I click source, I could look at where these are being published. So I published in functional ecology. I've got 2 preprints in archive. All of that information is there. Now, the really nice part about this is if I go up here, all of this I can copy and paste into the chat a link that anyone can now use. Oh, I sent that to host and panelists. Let me send this to everyone. Anyone now can click on that link and open up this exact same thing in their browser. And that's really important. If you want to create a very specific query, so let's start a new one. Let's say I'm Simon Fraser University, and I'm a librarian, and I want to just look at, oops, let me move this. And I want to look at my collaborations with University of British Columbia. I'll do that. These are all the papers I collaborated with UBC, but let's say I want to take out the works that have been retracted. So there's one retracted work, so let's say is not retracted. Let's say, for instance, I just want to look at journals that are in DOAJ. I'm going to click here and say, now show me just the journals that are in DOAJ. You can make a very specific query here. And then if you want, you can download this information, or you can take this out. If I go up here and say, don't show me the results, just show me the stats. And now you have a report that you can send to anyone that you want using that URL. Now, I said you don't have to sign up for OpenAlex, but if you want to sign up at the top, you can. You can see I'm signed in, and you can save searches. So if I go on here, these are searches that I've saved. As an example, these are some marine researchers at University of Tasmania in a department. I created a specific report, and now that's saved there. But you can also turn any of those into an alert. So anytime there's new publication on macrocystis, I get an email saying that. This is also free, but you do have to sign in to be able to use that feature. I also have one called All Reports, and you can see here, this is where I've put all of the different things I might want to look at, just to show how impactful you can make this. Okay, I'm going to put the results back, and I want to show a couple more things quickly. So the first is that at any point, you can understand what the API query underneath the user interface is. So you can see here when I look at, this is what the API call is that makes this website. You can also do that here. So view an API. But let me show you an example. So if I go back to Kyle Demes, if I'm looking at this paper, for instance, and I click API, right now you see all of the information we think you want to see, but we have a lot more data. And if you click API, it's going to bring up all of the information that we have on that entity. So this is just one publication, and this is all of the metadata that we have associated with that publication. So the API is very powerful, and we like to help people get to it, but obviously the user interface can be very helpful as well. The last thing I want to show before answering some questions All of this was looking at works or publications. It's not just papers. So to show you, you can see there's articles, preprints, reviews, book chapters. If I click on here, data sets, dissertations, books, there are a lot of works, but they're all works. The other thing you can do is search for authors, sources, or institutions. So let's say I want to look for journals. We have a lot of different types of sources. So I'm going to say, give me just journals. And I'm going to say, give me ones that have ecology in the title. So now I'm looking for, this is returning all of the journals that have ecology. If you want to be more specific and say, you know what, I want just the ones that are in DOAJ, it's going to give you just the journals that are in DOAJ. And this is a great way that you can find journals that you want to publish in. If you're not sure, you can then click on that and get more information on that journal. You can click View Works, so you can see what topics they publish on. You could see who are the leading authors that publish the most in this journal, all of that information. But you can also do this with authors. So if I type in Jason, you're going to get a whole bunch. There's 41,000 authors named Jason, but maybe if you want to be more specific and say Jason Priam, hit enter, you can see there's actually a couple of different profiles here for Jason Priam. But you could do the same sort of analyses. Show me the ones that have an ORCID, the ones that are in Canada, the ones that are at OurResearch, etc. And then the last one is the same idea with institutions. So let's say I want to look at institutions in Japan, and I want to look just at education institutions. Now we've got a list. And just like with any other entity, you can click on one of these and get information about that entity. So for instance, if I go to View Works, now you're seeing all of those publications. Okay,